Hello everyone, this is our second video on Unit 2. In last video we saw sphere. In sphere we have seen the equation of sphere, some basic properties of spheres. Regarding sphere, if you have any question, any doubt, you can ask me, okay? And also, if I missed any point, you can ask me or you can argue me in that case also. So let's start our today's video, and our today's topic is cone. Okay, in last video I told you that in next video I'll start with cylinder, but let's start with cone. It doesn't matter whether we start cylinder or cone. Okay, so I prefer to go this cone because this is quite longer than cylinder. Okay, now let's start our today's topic. Now first we see the definition of cone, and after that we'll see the equation of cone. Okay, now let's see the definition. A cone is a surface generated by a straight line passing through a fixed point and intersecting a curve or touching a given surface. The fixed point is known as the vertex and the given curve is called the guiding curve or directrix or base. Any line lying on this cone is called its generator or generating line. Okay, so by this definition I think all of you are very aware with this figure, and this definition defines that suppose if we have any straight line which passes through a fixed point. Okay, we are taking a straight line which passing through a fixed point, so one end point of this line is fixed. Okay, now what this statement says that if we move this straight line, okay, if we move this straight line along in this path, then this straight line generates a surface. This straight line generates a surface, and that surface is called the cone. Okay, this surface is called the cone. So it doesn't mean that all the time the cone should be like this. Okay, it might have in this case, or you can have this kind of figure. This is also a cone because the statement says that this is a surface generated by a fixed this is a surface generated by a straight line passing through a fixed point, okay, and touching a given curve. This is a given curve. Okay, this kind of structure or this kind of surface is called the cone. Now let us see the basic points of the cone. This point is called the vertex of the cone, and this fixed point is called the vertex of the cone. So all the line passing through this fixed point, okay, this point is called the vertex of the cone, and this straight line is the generating line for this cone. So, or you can say, if I draw any line on this cone, then all this line are the generator for this cone. Okay, and this curve, this given curve is called the guiding curve or directrix of the cone, or you can say this is the base of the cone. Okay, and this line, this dot line is the axis of this cone, and this small arc is the angle between the axis and the generating line of this cone, and this small angle is called the semi-vertical angle. Okay, so this is the basic definition of cone. Now let's see the equation of cone. So before to go on the equation of line, so if we see this OP, okay, if we see this line OP or axis OP, then suppose the coordinate of this vertex, O is at origin. Okay, suppose this is 0, 0, 0. Then the line passing through this point, 0, 0, 0 will be equation of line OP, that is axis, when vertex is at origin, will be how much? X by L is equal to Y by M is equal to Z by N. Okay, because in this case x1 is 0, y1 is 0, and z1 is 0. So this is the equation of OP when the vertex of the cone is at origin. Okay, now if the vertex of the cone is at, suppose say alpha, beta, gamma, any point, okay, then suppose in this case vertex is alpha, beta, gamma. In this case the equation of this axis will be x by alpha by L is equal to y by gamma by M is equal to g by, sorry, this is beta by M gamma by N. Okay, so this is the equation of axis when the vertex of the cone is at alpha, beta, gamma. Now next is we have a theorem. The theorem states that the equation of quadratic cone with its vertex at origin is a homogeneous equation of second degree in x, y, and z. Okay, so this theorem states that the equation of quadratic cone with its vertex at origin is a homogeneous equation of second degree in x, y, z. Okay, so it means if we consider the general equation of second degree in x, y, z, then if we able to show the homogeneous properties of that line, then that will be that homogeneous equation of second degree in x, y, z represents the equation of quadratic cone. Okay, so let's see the proof of this theorem. Let us consider the general equation of second degree in x, y, and z. you know the general equation of second degree in x, y, z. Be ax square plus by square plus cz square plus 2fyz plus 2gxz plus 2hxy plus 2ux plus 2vy plus 2wc plus d is equal to 0. So keep this as equation number 1. Okay, now we are considering the general equation of second degree in xyz. Be this. Okay, the next is we have a cone. Okay, we have a cone and we have given that the vertex is at origin. Okay, now we are considering any point alpha, beta, gamma on this cone. Okay, then so let alpha, beta, gamma be any point on the cone, then it satisfies the general equation of degree 2. Okay, so which implies, so this point will satisfy this equation. That means a alpha square plus b beta square plus c gamma square plus 2f beta gamma plus 2g alpha gamma plus 2h alpha beta plus 2u alpha plus 2v beta plus 2w gamma plus d is equal to 0. So give this as equation number 2. Now the equation of generator, the equation of generator passing through the point, passing to the point 0 0 0 will be, if we consider any generator for this cone, suppose this is our generator and this generator is passing through the fixed point. Our fixed point is 0 0 0. In this case the equation of this generator will be x by, so you know the direction ratios for this line will be alpha minus 0, beta minus 0, gamma minus 0. This is same as the alpha, beta, gamma, and you know direction ratios are proportional to direction cosines. Okay, so for that we can directly write that x by alpha is equal to y by beta is equal to z by gamma is equal to r say. Okay, say r, which is not equals to 0. Now from this we'll get the value of x equal to alpha r, y is equal to beta r, and z equal to gamma r. Now putting this values in equation number 1, we get, if we put all these values in equation number 1 in this equation, then we'll have a alpha r whole square plus b beta r whole square plus c gamma r whole square plus 2f 2f, I'm directly writing gamma beta into gamma r square plus, similarly we have 2j alpha into gamma r square plus 2h alpha beta r square plus 2u alpha r plus 2v beta r plus 2w gamma r plus d equal to 0. So from this, take r square is common from this equation, then you will get a alpha square plus b beta square plus c gamma square plus 2f beta gamma plus 2g gamma alpha plus 2h alpha beta to r square plus, take r is common, 2u alpha plus 2v beta plus 2 w gamma, take r is common, plus d equal to 0. Okay, now this is our condition. So to satisfy the equation, this equation equal to 0, so we know that r is not equal to 0 because we have already assumed that r is not equal to 0. So this implies that this term must be equal to 0 and this term must be equal to 0 and this term constant must be 0. If these three terms are 0, then only this condition satisfies, or this equation satisfies. Okay, because if a plus b plus c is equal to 0 such that c is not equal to 0, we know, then this, to satisfy the equation, this equation, a and b must be equal to 0. Okay, so this implies that, or you can say, since r is not equal to 0, which implies a alpha square plus b beta square plus c gamma square plus 2f beta gamma plus 2g gamma alpha plus 2h alpha beta equal to 0, comma 2u alpha plus 2b beta plus 2w gamma equal to 0, or from this you can write u alpha plus v beta plus w gamma is equal to 0 because 2 is not equal to 0. So, and the next is the constant d equal to 0. Okay, now from this, since we have u alpha plus v beta plus w gamma is equal to 0, and we have taken alpha beta gamma be any point beside, despite this is not equal to 0, 0, 0. So we are taking alpha beta gamma which is not equal to 0, 0, 0. It means we are not taking alpha beta gamma from the origin. Okay, so it implies that alpha beta gamma is not equal to 0. Okay, so this statement states that u is equal to v is equal to w is equal to 0. If this condition is there, then only this equation will be satisfied. Okay, so by using these same properties. Now we have this u is equal to 0, v equal to 0, w is equal to 0, and d is equal to 0. Now by using all these terms in equation number 1, okay, putting all the values u equal to v equal to w is equal to d equal to 0 in equation number 1, we get what we get: ax square plus by square plus cz square plus 2fyz plus 2gxz plus zx plus 2hxy plus all the remaining terms will be 0, and this equal to 0. So give this as equation number 3. Now look at this. So in this term we have degree 2 or power 2. In this terms we have 2, in this 2. Now in this f is constant, y into it also have 2 degree, it also have 2 degree, and it also have 2 degree. Now this implies that equation number 3 is homogeneous of degree 2. Okay, we proved that this equation is this is the homogeneous equation of degree 2. Okay, this implies that this equation number 3 represents the equation of cone. Okay, whenever you have given any homogeneous equation of degree 2, then that equation always represents a cone. Okay, so that is the case. So in that case, the vertex should be at origin. Thus equation number 3 represents a cone with vertex is at origin. Okay, so vertex should be at origin. So this is the equation of cone when you have given the vertex of the cone is at origin. Okay, our next topic is to find the equation of cone whenever you have given the vertex and the guiding curve. Okay, now equation of cone for given vertex and a conic directrix or guiding curve, or you can say base. Okay, so in this case we have given a vertex of cone alpha, beta, gamma, c, which is not at in origin. Okay, in this case the vertex of cone is not at in origin. So this is our cone. In this case our vertex, say v, is alpha, beta, gamma. Okay, and we have given this as conic guiding curve. So conic means ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, z equal to 0. So this is the equation of conic. Okay, now in this case we have to find the equation of cone. Let us consider any point v, alpha, beta, gamma be the vertex of the cone, or you can say of a cone with a conic guiding curve, or you can say base. Conic guiding curve ax square plus 2hxy plus by square plus 2gx plus to fy plus c equal to 0, comma j equal to 0. Give this as equation number 1. Okay, now using the same process, since any line passing through the point alpha, beta, gamma, or passing through the fixed point vertex alpha, beta, gamma will be, so in this case, x minus alpha by L is equal to y minus beta by m and j minus gamma by n, where this element are the direction cosines of that line. Okay, so keep this as equation number 2. Now this line will be the generator of this line if this line intersect or touch this curve. Suppose we are taking this line, okay, so this line now passing through this point. Okay, now this line will be the generator for this cone if this line touch the guiding curve this, or if this line intersect this guiding curve. Okay, then this line will be the generator for this cone. So since the line, equation number 2 will be the generator for the given cone if it intersects the guiding curve or directrix. So the line 2 meets the plane. Suppose this line 2 meets the plane at z is equal to 0 at, so suppose in this case if this line meets that plane, this plane means this, okay, at z equal to 0, then from this you can find the value of x and y. So from this equation, so what is the value of x? X minus alpha by L equal to y minus beta by m is equal to, in this case z is 0 minus gamma by n. So from this we will get x equal to alpha minus L n L gamma by n. Similarly y is equal to beta minus m gamma by n. Okay, so thus this line meets the plane, this plane z equal to 0 at which point? Alpha minus L gamma by n, beta minus m gamma by n, and 0. Okay, so if this point lie on the conic, suppose if this point lie on the conic 1, then so what will be the case? Use the value of x equal to this, y is equal to this, and z equal to this in this conic equation, this equation number 1. Then a alpha minus L gamma by n whole square plus 2h alpha minus L gamma by n into beta minus m gamma by n to h xy plus b beta minus m gamma by n whole square plus 2g alpha minus L gamma by n plus 2h, sorry, 2f beta minus m gamma by n plus c equal to 0. Okay, so give this as equation number 3. Now this is the condition for the line 2 intersects the conic 1. Okay, so if this equation is equal to 0, then in this case the line 2 lies in this conic, okay, or intersect the conic or touch the guiding curve conic. Okay, now eliminating LMN from 2 and 3. Okay, we have, so you know what is the value of L here. L is from 2, L is x minus alpha, m is y minus beta, and n is y minus, sorry, z minus gamma. So use the value of L equals to this, m equals to this, and n equals to this in equation number 3. Then you will get a alpha minus, so what is the value of L? X minus alpha gamma by, what is the value of n? Z minus gamma whole square plus 2h alpha minus x minus alpha gamma by g minus gamma plus b into beta minus y minus beta gamma by g minus gamma whole square plus 2g x is alpha minus x minus alpha gamma by g minus gamma plus 2f beta minus y minus beta into gamma by g minus gamma plus c equal to 0. So equation number 4 will gives the equation of cone with given vertex and a conic directrix. Okay, now this equation number 4 will give the equation of cone. Okay, now in this case if we put the given values of alpha beta gamma and the guiding curve, then the remaining equation will be will represents the equation of cone. Okay, so this is long equation, you can understand by doing an example. Okay, so let's do an example related to this problem. Find the equation of cone whose vertex is 0, 0, 3 and base is the circle x square plus y square equal to 4 comma z equal to 0. Now in this case we have to find the equation of cone such that we have given a vertex which is not at origin and we have given a directrix or base for this cone that is in the form of conic. Okay, so in this case our conic is circle. Okay, now solution. So we have a guiding curve x square plus y square is equal to 4 comma z equal to 0. Okay, with this guiding curve. Now the next is, since the equation of any line or generator, equation of line through the point 0, 0, 3 will be x by L equal to y by m equal to z minus 3 by n. Okay. Now at z equal to 0, so in this case x equal to minus 3L by n, y is equal to minus 3m by n. Okay. Now x, y, z is on the curve. In this case x, y, z is on the curve. Then 3L, so using the value of x, y in this curve, because we already know that this values x, y and z are lies on this guiding curve. Okay, so this means 3L by n whole square plus minus 3m by n whole square equal to 4. Now again from this equation you can find, because we have to eliminate L, M, N. Okay, so from this, okay, now from the equation x by L equal to y by m equal to g minus 3 by n, from this you can find the value of L by n. L by n equal to x by g minus 3, z minus 3. Similarly, L by m equal to y divided by z minus 3, because our aim is to eliminate L, M, n. Okay, so from this you just put the value of L by n minus 3. What is the value of L by n? X by z minus 3 whole square plus minus 3. What is the value of m by n? Sorry, this must be m by n. Okay, m by n. M by n is 3 into y by z minus 3 whole square equal to 4. Now this will be 9x square plus 9y square equal to 4 into g minus 3 whole square. From this 9x square plus 9y square, 4j square minus 4j square, this is minus, plus 4 to the 2 3 is 6, 6 4 is 24, z minus 9 into 4 is 36 equal to 0. So this is the equation of plane. Okay, this is the equation of plane when the vertex is at 0, 0, 3. Okay, now the next is condition for general equation of second degree represents a cone. Now when the second when you have given the equation, general equation of second degree in x, y, z, then to represent the equation of cone, by that equation there is a condition that suppose we have a general equation ax square plus by square cz square plus 2fyz plus 2z zx plus 2hxy plus 2ux plus 2vy plus 2wz plus t equal to 0 is the general equation of second degree. Then values for a, b, c, d, f, g, h, u, v, w, if the determinant of a, h, g, u, h, b, f, v, g, f, c, w, and u, v, w, d equal to 0, then this equation number A represents a cone. Okay, if for a general equation of second degree, if this condition is satisfied by the parameters of this equation, then this general equation will represent a cone. Okay, so if you have given any general equation in the form of this equation, then if you are able to find this and if you show the determinant of this equal to 0, then the given equation is the equation of cone, or the given equation will represent the equation of cone. Okay, so this is the condition. Now, so we have a very interesting note. Okay, for second degree equation, that is fxyg. Okay, now first we introduce a new variable t, and the value of t is approaches to 1, or it is almost equal to 1. Okay, to make fxyg t as homogeneous equation. Okay, now it means first we see the general equation of second degree in xyz by this, and this is same as fxyz. Okay, now if we consider this equation, if we denote this equation by fxyz, then in this case this is not a homogeneous equation. Okay, generally this is not a homogeneous equation. So to make this homogeneous equation, we have to introduce a new variable t such that the value of t approaches to 1. Okay, it tends to 1. So if we introduce this variable in this equation to make the equation of this fxyz t as homogeneous equation. Okay, so for that fxyz t equal to ax square plus by square plus cg square plus 2fyz plus 2gzx plus 2hxy plus 2ux. In this case it is only 1 degree, so we have to make all this equation as homogeneous equation. Then we are introducing a new variable here t, plus similarly for the next term 2vyt plus 2wgt plus dt square equal to 0. So now if we look at this equation, so this is the equation, homogeneous equation of degree 2. Okay, so this is our aim, because in first case we do not have a homogeneous equation. Okay, this is not a homogeneous equation. To make this as a homogeneous equation, we have to introduce a new variable t, such that the value of t is approaches to 1. This is very almost equal to 1. Okay, or you can say t equal to 1. So in this case we are introducing here and here to make this equation as homogeneous equation. Okay, after that, then we equate del f by del x equal to 0, del f by del y equal to 0, del f by del z equal to 0, del f by del t is equal to 0 by putting t tends to 1 or t equal to 1. Okay, so by using this four equation, so this is equation number 1. It will give one equation, and it will give second, third and fourth. Okay, by using this four equation, we will get the values of x, y and z, and that will satisfy by the vertex of the cone. Okay, so if we find the value of x, y, z from this equation, suppose the value of x is x1 or x prime, y is y prime, and z is z prime, then this will be the vertex of the given cone. Okay, now let's see the example. Show that equation x square plus 2y square plus z square minus 4yz minus 6zx minus 2x plus 8y minus 2z plus 9 equal to 0 represents a cone. Find the vertex. Now we have to show whether this given equation will satisfy or will represent the equation of cone or not. After that, we have to find the vertex of this cone. If this satisfies, or if this equation represents a cone, after that we have to find the vertex for this cone. Okay, so for that, first we have to introduce a new variable, because this is a equation f(x,y,z) such that this is not a homogeneous. Okay, first we have to make this equation as homogeneous. If you have given this equation in the form of homogeneous, then you do not have to introduce a new variable. You can directly find the value of x, y, z. Okay, so for this we have to introduce a new variable. Okay, now solution. Introducing new variable t ht approaches to 1 for the given equation, then f of x, y, z, t will be x square plus 2y square plus z square minus 4yz minus 6zx minus 2xt plus 8yt plus 2zt plus 9t square equal to 0. Now del of f by del of x will 0 implies that, so del f by del x is 2x minus 6g plus 2t equal to 0, which implies as t tends to 1 or t equal to 1, x minus 3g minus 1 equal to 0, give as equation number 1. Now, similarly, df by dx equal to 0 implies y minus g plus 2 equal to 0 as t tends to 1, give as equation number 2. Similarly del f by, this is del y, del f by del z equal to 0 implies z minus 2y minus 3x minus 1 is equal to 0 as t approaches to 1, give as equation number 3. And the last one is del f by del t is equal to 0 implies x minus 4y plus z minus 9 equal to 0 as t tends to 1, give us equation number 4. Now from this 4 equation we have to find the values of x, y, z. Okay, now using 1 and 2, x equal to 3z plus 1, y is equal to z minus 2. Okay, from this 1 and 2 we'll get the value of y in terms of z and the value of x in terms of z only. Now use the value of x and y in equation number 3. Putting the values, these values in equation number 3, we get what we get. Z minus, what is the value of 2, z minus 2 plus, sorry, minus 3g plus 1 equal to 0 implies that minus 10z plus 0 is equal to 0, which implies z equal to 0. Now we found z equal to 0, which implies x equal to, so from this x equal to 1 and y is equal to 2. If we put the value of x equal to 0, y equal to 0, x equal to 1, y equal to 2 and z equal to 0 in any of these 4 equations, then it will satisfy. Okay, now since x equal to 1, y equal to minus 2 and z equal to 0, satisfying equation number 4, thus the given equation represents a cone. Okay, now and the vertex will be 1 minus 2 0, so value of this will be the vertex of the given equation. Okay, now for today we'll see the last subtopic, that is right circular cone. Okay, we just see the definition and the equation for this cone, right circular cone. Right circular cone, So look at the definition of this right circular cone. The surface generated by a line passing through a fixed point. That fixed point is the vertex, and making constant angle with fixed line. That fixed line is axis through the vertex is known as the right circular cone. So the difference between the normal cone and the right circular cone is that the angle mixed by this line, any line with a fixed line, this fixed line is axis, is always same. That means that suppose this is theta 1 and this is suppose say theta 2. In this case theta 1 equal to theta 2. So for this any theta 1 and theta 2. Okay, so this is the case of right circular cone. In the normal cone, this is not equal, or this is not necessary to equal theta 1 equal to theta 2. So if the theta 1 equal to theta 2, then that will be the cone, but to have a right circular cone, this must be equal. Okay, theta 1 must be equal to theta 2. So the equation, that constant angle is called the semi-vertical angle. Okay, and the equation of right circular cone is given by cos theta equal to L x minus alpha m y minus beta n g minus gamma whole divided by root over L square plus m square plus n square into root over x minus alpha square plus y minus beta whole square plus g minus gamma whole square. Okay, so from this we'll get this equation. Now again, if the vertex of this cone is at origin, then this equation will become this. Okay, so this is all about the right circular cone. In next video we'll see the angle of lines in which the plane cuts the cone. Okay, after that we'll have some I think 3 more subtopics on this cone. After that we'll go with the cylinder. Okay, so for today I'm stopping here. Thank you all.